So we've talked about Boyle's law and Charles' law. We can actually combine these two together in what we call very creatively the combined gas law. This relates pressure, volume, and temperature. So in this, we're assuming that the amount of gas is constant, which is pretty reasonable. So you have a container of gas. You know, it could be a balloon or a syringe or some container of gas. And so you're not letting gas out or you're not letting gas in. The amount of gas is the same, but now we're allowing temperature, pressure, and volume to all change at the same time. And so the gas law gets a little bit more complicated. Can you see where those two other gas laws are in here, though? Mm-hmm. So here we've got P1V1 equals P2V2. There's Boyle's law. And if we leave the P's out, then we've got Charles' law. So they've just been combined.
How long did that for them to do, like 100 years? Or
no.
Right after Boyle's law?
You know, I don't know for sure, but it's just a matter of very simple algebra to combine those. So now this one has even more words. Always read the entire question first. A sample of gas has an initial volume of 158 milliliters at a pressure of 735 millimeters of mercury and a temperature of 34 degrees Celsius. If the gas is compressed to a volume of 108 milliliters and heated to a temperature of 85 degrees Celsius, what is its final pressure in millimeters of mercury? That's a lot, isn't it? We can do this. This is not hard. We just need to make a table because it's a lot of numbers and they're easy to get mixed up. So we're just going to make a table. So the first thing we come across is 158 milliliters. So we're going to make our table here, and we're going to have condition 1 and condition 2. And so 158 milliliters, that is a volume, right? Pressure of 735 millimeters of mercury. That's the pressure. And a temperature of 34 degrees Celsius. Can we use Celsius? No. Let's convert it right away before we forget. Plus 273, I think that ends up to be 307. Is that right? You know, I'm going to not have enough room here. That equals 307. I'm probably still not going to have enough room, but at least I tried. You okay with how I got that? Okay, if the gas is compressed to a volume of 108 milliliters, okay, so 108 milliliters, and heated to a temperature of 85 degrees, so we have to add 273. 273 plus 85, 358. What is the final pressure? Oh, good. Our table here has one empty box. So we're looking for P2. Now we need an equation. We look at our table and see what we have, and that helps us to choose, because now we have 3 equations to choose from. We have 3 different things that are changing. So Boyle's law or Charles' law by themselves is not going to help us out. So we need to use the combined gas law. So we write that down. P1 V1 over T1 equals P2 V2 over T2. And we see fractions. We're solving for P2. So this is what we're looking for, P2. We need to get rid of the fractions. This is not as troublesome because what we're solving for is in the numerator. It's when what you're solving for is in the denominator that people lose their minds and end up with solving for the reciprocal of what they're looking for. So we need to rearrange this equation. We can cross multiply and then clear things out. And I think what I'll do is, no, there's just no space anywhere. Okay, we don't need this problem anymore, do we? I'm going to just cover up the problem. That's about the right color. Make it really fat. So I'm just going to cover this up so that I can have more space to write. How's that? That's good. Isn't that nice? I love this thing. It's like, yeah, I went to work and I drew on my iPad. It was fun. Okay, so if we cross multiply this guy, and I want to work this out because I know some of you, it's not you, it's how you were taught, right? You weren't taught very well how to do algebra, and so, but you can learn how to do this. We just need to know a few things. So we're going to cross multiply. So we're going to take these two and multiply, and these two and multiply. So we end up with P1 V1 times T2, and that's equal to T1 P2 V2. When you're multiplying things, the order doesn't matter. Adding and subtracting, it matters. But if you wrote P2 V2 T1, it's exactly the same. But you have to have them on the right sides. So I will again put in red what we're looking for. This is the guy we're trying to find. And so we are going to divide by everything that's next to him on that side. Over here, we want T1 to go away, so we're going to divide by T1. If we do that to one side, we have to do it to the other side so that it stays equal. Over here, we're going to divide by V2 because V2 over V2 is 1. And so we have to divide by V2 on the other side. And look, we made a TV. Yeah. I wonder if we could make a TiVo. P2 equals P1 V1 T2 over T1 V2. It's worth the 5 seconds to double check that you copied that correctly. Really easy to copy it wrong. So this equation right here, when you show your work on something, even for the online homework where I don't actually see your work, you should write that equation on your paper. If you can rearrange that in your head, and some of you can, that's fine. But write this equation down. That's like the first thing is the table. The second thing is the equation. And now we take the things from the table and plug them in. And so we're going to find P1. Okay, so that's 735 millimeters of mercury. Write the units. And V1 is 158 milliliters. And T2, we're going to use the Kelvin one, is 358 Kelvin. And all of that is divided by T1, which is 307 Kelvin, times V2, which is 108 milliliters. Everybody with me? Now let's check our units. Milliliters cancel, kelvins cancel, and we're left with millimeters of mercury, which is a unit of pressure, so that's a good sign. Doesn't prove that we did it right, but it's a good sign. If you ended up with milliliters, that would be a bad sign. So now you need to punch this through in your calculator. And this is where I always have students miscommunicate with their calculators. So get your calculator out and actually do this with me. So we're going to take 735 times 158 times 358 divided by 307, and this is where people come into a problem. We're going to divide by 108. And we're going to get 1,254. How many sig figs should we have? We should have 3. So
1.25 times.
we're going to write it up here. We get 1.25 times 10 to the 3 millimeters